This is Statistics 243, Monday, September 22nd, the 10th class of the semester. Okay, did everybody put their GitHub name on the piece of paper on their assignment? If anybody didn't, please come up and make sure you did do that, because otherwise Jared's going to have trouble matching what assignment goes with what name. And if you haven't stapled it, can you use the stapler here? Okay, so let's go ahead and get started. Okay, so the plan for today is I'm going to walk through some demos of debugging in R and show you some of the tools that you can use for debugging. And as usual, the idea is we're doing this in R, but a lot of the ideas of sort of the things that you would do, there are analogs in other languages, so it should be pretty easy to pick up some of these tools in other languages as well. In this unit, I have a bunch of stuff on sort of good practices for coding and for reproducible research and that sort of stuff. I'm not going to talk a lot about them in class, apart from the debugging stuff. But what I would like you to do is read through this on your own, and we're going to have next Monday in section, I'm going to ask you guys to read an article in advance, and then we're going to have some discussion both of some of the material that's in the unit and of that article that I ask you guys to read in terms of reproducibility and good practices for sort of workflows and coding and things like that. So that'll be next Monday in section. And then we'll start in on Unit 6 probably on Wednesday. And the focus there will be on thinking about writing efficient code and thinking about memory management, thinking about copying and not versus not copying, and how to write code that runs more quickly. And then a few more specialized topics, including some stuff on object-oriented programming. Okay, so any questions from last time? Okay, so I'm going to skip over the first bit here. One thing I will point out specifically is a couple things here. One is when you've got code that is not working for one reason or another, and you're trying to figure out why it's not working. Oftentimes you've got that the problem is embedded in some very large chunk of code. So you've written a few hundred lines of code, and for some reason it doesn't work, and you're trying to figure out what's going on. So usually a good first step is really to try and isolate down the problem to exactly where it's happening, and particularly if you think there's something wrong with the software that you're using and you want to ask for help online, you generally want to try and isolate the problem down to a very small, specific, reproducible example. So you don't want to say to somebody online, hey, I need help with my problem, here's 500 lines of code. You want to say to the person, you want to say online, hey, I'm having trouble with this, here's 10 lines of code that are really a concrete, specific example of what's not working for me. Does anybody have any suggestions? So both if you're asking for help and if you're trying to sort of narrow down to where the problem is in your own code, you really want to try and sort of burrow deep in there and see exactly where exactly the problem is happening and get basically the smallest example that you can of it. And sometimes when I'm debugging stuff and things are not working, I'll basically end up sort of stripping away everything until I'm down to just a few lines of code that are executing something, and that's still not working. And then I know the problem is there, and I can really concentrate there on trying to figure out why that chunk of code is not working. It can also help to try and figure out if the error that you're getting is stochastic or not. If you close R and restart it, does the exact same thing happen? If you run the code with a different random seed, does the exact same thing happen? So those sorts of things can also help in terms of trying to figure out, sort of wrap your head around where things could be going wrong. Since we talked about a lot about scoping last time, I thought I would mention this little trick that we can use. So in the Code Tools package, I'm going to switch over to R here. There's a nice function for figuring out what are the global variables that are used in a function. So oftentimes a problem with your code, particularly if you find that it works in one context and then it doesn't work in another context, or it doesn't work for somebody else, is that you're relying on a global variable without realizing it. And so if you sort of change the context of where you run your code, the answer may differ, and it might fail in one case and succeed in another. So sometimes that will be because you're not actually, you haven't been careful about whether you're using a variable that you're relying on scoping to find that variable versus using a variable that's local to your particular function. So an example of that is you can use this find globals function. So if you asked that question, if you said find the global variables that are used in the LM function, and there are tons of them that are used in here, and you'll see that mostly they're just sort of core R functions. So in LM, minus and the not operator and not equals and brackets and assignment and all of these other sort of core functions get used. And that makes sense because anytime when we're calling these sorts of standard functions, they're going to have to be found via the scoping rules in the search path. But when you're writing your own function, and obviously here's just a silly example. I've just written a function. It's a two-line function. I haven't rated on one line where I separate things with semicolons. But I'm assigning a local variable y, but then I'm printing out x plus y, but x never appears in the code. So you can obviously look at this and say, oh, you're relying on a variable x that has to be found by R's scoping rules when I present to you a two-line piece of code here. But it's often much harder if you've written a function that's 20 lines or 50 lines or 100 lines, or if you have a whole set of a bunch of different functions. So this find globals can help there in that it'll say, oh, you know, your function f, okay. All of these things I would expect have to be found by the scoping rules. But, hey, you know what? You've got something that's called x that is being found by the scoping rules, and that's probably not a good idea in this case. In general, it's not a good idea to have variables found in that way that are not just standard functions. Another thing that you can do is basically control what happens when R has a warning or an error message. And so when R gets a warning message, what it will do is it'll either print it to the screen, or often it will basically save up all those warnings, and then it'll say, hey, there were more than 50 warnings issued. Do you want to see what they are after the end of a block of code is executed? And that can be fine, but sometimes there are warnings and you just want to turn off the warning because you know the code is executing fine and the warning is not important to you. Or other times you want to try and get rid of the warning message. You're worried that it's an error, or you've written the code and you don't want to give somebody a piece of code that issues a bunch of warning messages because then they won't really know if it's something to be concerned about or not. So we can basically alter the behavior of R in response to either an error or a warning. And if you look at help on options, it should give you some information about that. So if we check down here, so let's see, so that's not quite what I was looking for. So I guess the main thing I'm looking for here is so warn here basically says how warnings are handled, and you can basically set the warn option. Managed to forget how to make this bigger. But this basically sets the handling of warning messages. If the warn option set via the options function is negative, all the warnings are ignored. If it's 0, they're stored until the top level function call is returned, so until basically the body of execution that you're doing finishes. But you can also change this. So for example, you could set if you set the warning level to 1, it'll print out the warnings as they occur, which can be helpful because then you'll know more specifically where the warning is happening. Or you can actually have a warning turned into an error such that the code will stop. And that can be useful because if you want to see exactly where the error is happening and what the state of the code is at the time of the warning is issued, then you might want to have the warning treated as an error, have it stop, and then the tools that we're going to talk about in a couple of minutes for dealing with errors you can apply to dealing with warnings as well. So that can be useful. And I just have a little example here of how you would do that. I won't run this code, but you have this in your have this available to you if you want to try it out. Okay, so let's now turn to debugging. So if you were writing code in a language that gets compiled like C or C++, debugging is a bigger deal than in R because you write your code, you then compile it, and there might be a bunch of syntax errors that you have to fix, and then you run the code, and the code may give out an error, but there's no way to sort of see exactly what's happening at the point of which the code is operating. So there have to be really nice debugging tools for debugging, say, C code that allow you to basically start up your executable and step through the lines of code individually to see what happens after every line of code and what the state of the different variables is so that you can try and see what's going on when an error happens. Well, in R, since it's an interpreted language, we can just cut and paste or run individual lines of code. So in some sense, we don't even need a debugger. We can just try and debug by just running the code in chunks or in lines of code, and that's often what I would do or what you guys presumably do. But there are lots of cases where it's helpful to have more formal debugging tools to ferret out what kinds of errors are going on. And so the basic, as I sort of see it, there are a few different functions and sort of functionality that I'm going to show you. But as I see it, basically there are sort of two basic things we're needing to do here. One is to basically see what the call stack is at the time that an error occurred. And that would allow you to see that, oh, I ran this complicated piece of code. The error happened in the fourth function on the call stack. That function was called from here, that function was then called from here, and I can know sort of what the set of functions that were called that gets me to the error. So that'll give me a handle on where the error happens. The other thing that can be helpful to do is basically to be able to step through your code line by line, and at the state where you think an error is happening, basically look at all of your variables, see what the values of the variables are, and that will often allow you to basically see why the error is occurring and how the error is occurring. So the tools that we're going to see are both going to allow you to look and see what's the call stack, what are the functions that have been called at the point that the error occurs, and will allow you to step through the code or basically either step through the code all the way from the start or step into the code at a particular place where you'd like to stop it and then allow you to step through the code line by line from there. Okay, so that's sort of the name of the game. So how many of you have used a debugger in some other language like C or Python or something like that? Okay, so just a few of you, not very many. Okay. Okay, so the other distinction here is oftentimes it's going to be easier to debug code that you're writing because you have sort of control over that code and control over how it's run. But if the error is happening because you're sending something in to, say, the LM function, you have much less control over the LM function. You can't rewrite the LM function easily to do something slightly different and then rerun it because the LM function is part of R. It's not really under your control. So one of the things we can do is to any function, be it one that you create or a function that is already existing in R, we can say debug of that function. And then the next time we run that function, it's going to start the debugger and it's going to basically put you into the function and allow you to step through the function line by line. So that's sort of one of the very core tasks of a debugger. So let's go ahead and do this. And I'm not sure why I have this line of code here, but maybe it's important for some reason. Okay, so now I'm going to run the LM function on just one of the basic objects in R. So what happens is it basically gives me this little interface here that looks sort of like a regular R session, but it's going to have browse here. And that basically says that I'm now browsing through the function and I can step through the code. And it basically also prints out all of the code that just came into relevance here. So it says I'm debugging in this particular function with this particular set of arguments, and this is the code that I'm about to step through. And basically, if you're at the start of the function, then it sees the open curly brace for the whole function. It says, oh, the next thing you're going to execute is basically the entire function. So it basically is going to print that out. And now if we start stepping through, it'll start stepping through the individual lines of this function. So the way this will go is you'll be down here with the browser prompt. And you can do things like printing out what an object looks like. You can step through a line of code, or you could say continue, and that'll just continue executing all the rest of the code until it reaches some other breakpoint. And I'll talk about breakpoints in a second. So I could do something like this. So I know that I know that this was the call that was made. I know that the lm function is going to do a whole bunch of stuff with the data object, whatever gets assigned into the data argument of the lm function. So I might be interested in just checking, what's in the data object. Does it look okay here at the very start of my function? Okay, so I can just do that. Sometimes you'll need to actually type the print because there are some special characters here that control the operation of the debugger. So if I wanted to see what the value of n was, which is in this case in the global environment, I have to say print n instead of just n because n stands for running the next line of code in the debugger. So a couple of the key characters that you would use in the debugger are n for next, and that'll be the next line of code, and c for continue. That means basically just continue and run all the rest of the code up until the next point that the code might stop. There might be a few others. I might actually be able to just do print p of n. Let's see. No, that doesn't work. Does this work? No. Okay. Okay, so now I can do something like this. I can just type n, and then what the way this works is this says, okay, the next thing that's going to get executed is this line of code. It hasn't done this yet, but if I now type n again, it will have already done this, and then it says, oh, the next line of code that's going to get executed is this line of code. So maybe I've already gotten a sense from some other work I've done with my particular problem, and I already know somehow that this is the line of code at which the problem occurs. Okay? So here I am, I've executed all the way up to and including this line of code, and I say, hey, you know what? Maybe I'll try and find a more interesting example. Also, if you hit return, that will usually just also continue stepping through the code. So I'm going to see if maybe I can find something that looks like an interesting thing to look at. So maybe I got some sort of error message that made me think that there was something wrong with this line of code. And I'm like, well, I don't know what's going on. But if I can step into this point, and I can say, oh, what's in this MF thing? And is that what I'm expecting it to be? Well, okay, we haven't really talked about the details of what's going on in LM, so maybe this isn't going to be all that helpful. But if we sort of knew what LM was doing and knew what this line of code was doing, we could look in here and say, oh, does this look like it should be causing a problem or not? And I could even do something like, at this point, I could like change MF, and I can actually execute other code here. So I could say, I could do something like, maybe I want to go in and change this to be just the first 5 rows. Maybe I think something weird is going on later in this object that gets passed into the model.response function. So I could also run a little bit of code in here and see what the result is at the same time. And the nice thing about running the code here is that all of the other objects in this environment, all of the scoping rules are exactly as they would be for if I ran the next line of code in this actual function. Whereas if you were like trying to cut and paste code into your global environment, you wouldn't have all of the context wouldn't be set up in the same way that it is in this particular function. So that's sort of the idea of being able to execute code within this context. Okay, any questions so far?
So if you run that line and keep going, it will just like adjust the code?
Yeah, so that's a good question. If I just run this line, I could assign the output to something, but I still haven't run the line that it was all queued up to run. So I still haven't run this line of code, which is actually the line in the function.
Yeah.
So if I were to do this, it'll run this line of code and print out the output. But if I now type next, it's still going to go and run this line of code. It's not like I've replaced that. It's just like I've run an additional line of code in addition to that. Does that get at your question?
Yeah, I guess I still don't really get then how this is helpful if you're not like adjusting the code as you go through it, or like
yeah,
just go one step at a time just to like, I don't know, I guess I'm not really.
No, it's a fair question. I guess the reason I like to go one step at a time is if I can isolate the line in which the problem occurs, it's usually going to be because somehow the input that's going into that function is not quite what I expect it to be. And in that case, I can look and see exactly what is the input, in this case, say, going into this model.response function, and does it look like there's a problem with the inputs? Or, and as part of that, I could adjust the inputs and say, do I really understand what should and shouldn't go into this function? So I could modify, what I was illustrating down here was I could modify the inputs and see if that works and if this gives me an error message. And then maybe I could get some understanding of why that line of code up there that I haven't yet run, why is it executing differently than this when I sort of modify the input? So it's sort of just a trial and error way of sort of getting in there and probing how things change depending on what inputs I pass in. Yeah?
Will
Yeah, so if you have a for loop, if you keep typing n, it'll basically go through every iteration of the for loop, which can be helpful if the problem is occurring in the for loop, and real pain if the problem is after the end of the for loop, right? Because then you might be 1,000 times hitting n until you finish up the for loop. So I'm going to get to a way where we can basically insert a line that says put a breakpoint here, and you put the breakpoint potentially after the for loop. So if you had the breakpoint after the for loop and you hit C for continue, it'll run through all of the for loop and it'll run up through all of the code up until the point it gets to that next breakpoint, and then you can continue stepping through. Yeah, we'll see that in a second. The basic answer is what we're going to do is we're going to insert a line of code that says browser into the code that we want to run. And if we're in the middle of a for loop, we could wrap this in an if statement. We could say if I equals 7, if we knew the problem happened on the 7th iteration, then call the browser. And the browser in this sense just means put a breakpoint here and then allow me to step through the code in the same way that I'm doing with the debug function here. Is there another question, JR?
Can you actually modify anything? So let's say at this point I haven't run line 21, right? And
Right.
then what if I do like mf equals to 3 or something? Then does that actually change?
Yeah, I mean, that's sort of what I was trying to get before. Is I don't know if there's a way that I could change it and then.
So if you type mf, like.
Well, I guess I could. I could run this line of code and get back the y, and then suppose I actually wanted to see what would happen if I had run this line of code with a different input and gotten back a different y. Right. So I can do. The line of code that's about to be executed is that 21st line. So I can do next, and it executes it. And now I could say, you know what I really want to do is see what happens with the code if I change this to be whatever, just the first lines here, and maybe I change this to be character. I have no idea what this means, but now I could do this, and I think what should happen now is y should be changed in this context, and now any lines of code subsequent to this, after this, will use this new y.
Oh, okay, so you can actually modify. It's possible that one man was actually modifying NF by argument.
Yeah,
you can
so
modify this, and then the next steps you will take your modified argument.
Yeah, exactly, right.
Okay.
So I think that should work, and so I'm glad you sort of raised the question in a different way because maybe that helps address Greta's question. Yeah. Other questions or comments? Okay, so that's the idea of. Okay, so you can see if we were playing around with trying to change this, it doesn't like the fact that I changed it to character. That might or not be helpful in whatever situation I was in. Okay, let's see. So I'm just going to hit. Let's see. I guess we've already sort of seen this a bunch of times. I'm going to hit continue, and in this case, there are no breakpoints in this function. So this just should continue and finish up the whole operation, and then I'm back to my usual prompt here. Okay, so. Let's see. And if I don't, the next time I call lm, it will still continue to debug until I call the undebug function on the lm function, so that I stop being in this debug mode. Okay, so the next thing I want to say, and we're gonna get to how do I insert these browser statements, these breakpoints after this. But the next thing I want to talk about is how would I even know where an error occurred? Where in the call stack, what line of the given function, and which function is it in which the error is occurring? And sometimes this can be kind of hard to decipher, particularly if you're doing a bunch of like applies and applies and things like that. So you guys already saw in the problem set that when you call sapply, it then calls lapply, and then that calls whatever anonymous function you guys are getting is being passed into whatever function is being passed into the lapply. And so exactly where an error is occurring is sometimes a little bit hard to determine. So what I'm going to do here is this is an example of some code where there are a few different functions that are being called. It's not all that complicated, so it's not as realistic as we might like. But there's going to be an error that occurs here when I call it in the way that I call this particular function. So this is some sort of statistical code that is trying to do a jackknife, which is sort of like a bootstrap. It's basically trying to get a standard error by basically holding out individual observations and seeing how much your parameter estimates change when you hold out an individual observation from the data set. So I won't go into in detail what this code is doing, but that's sort of the basic overview here. So I've gotten the functions in my environment, And now I'm going to call this function on a data set. And so my idea is, okay, I think this should be some general jackknife thing that should work on a data set. And for some reason, I think it should work on this particular, I think this is just a vector of cat heart weights. And the idea is, I think, to sort of get a jackknife estimate of, say, the standard error of the population mean or something like that. Or the standard error of my estimator of the population mean. And yet when I run it, here's what happens. I get back this error message that says, is.atomic of x is not true. Okay, so what do I do now? Right? This is actually fairly realistic. You get back an error message, and you have no idea where in this code the problem occurs. And the error message, maybe this is probably a perfectly correct error message in terms of what the actual error is, but I have no idea why it's happening, and I have no idea even where to start of trying to find the problem. Okay. So I could basically start debugging through each of those functions that I just ran, and I could basically step through line by line into the first function, and then when it calls the next function, I could debug the function that's called from within the first function and step through the second function, and maybe that second function calls a third function, and I could call the debugger on the third function and step through that. And eventually, after stepping through many lines of code, potentially, I might figure out where the error occurs. That's really slow, particularly if you've got a lot of nested functions that are being called. So instead, I'm going to do something, I'm going to call this function traceback, and that's basically going to show me the call stack of what functions were called up to the point at which the error occurs. So if I do that, it says, okay, here's what's going on. So first you called the gamma.jackknife.to function. Okay, that makes sense. That is what I actually called as the user. And then from there, some calcvar function got called. In particular, I guess this is at the 9th line of this function. And then from there, an apply was called. And then there was an anonymous function that was called in the apply, which must be the var function in this case, because that is what's the function that is being, I guess it's not anonymous in this case, it's named, but this is the function that is being passed into the apply. And then within that function call, there was some sort of stop error that occurs when it was doing some sort of checking on some x. So then the question is sort of, where does this x come from? And how is it being used in this particular context? But this at least gives us a decent idea of, oh, okay, something's going wrong with applying the var function by column to this estimates object that must be living in the calcvar function. And maybe if I sort of get into this level of the code, I can see what's happening. Okay, and I can see what's wrong with, presumably this x probably relates to, is probably the name of a local variable to which the estimates object got assigned or something along those lines. Okay, so any questions at this point? Okay, so that can be useful. I now have a good sense of where the problem has occurred. I could, for example, say, do my debug, apply my debug function to calcvar, and I could go into calcvar directly without having to go into this function and then step through. So that would be a perfectly legitimate thing to do. Another thing I can do is use traceback in a somewhat different way, which is if before I run the function that causes the error, I issue this, I change this option in R. If I say set the error option to be recover, it will basically do the same thing as traceback just did. It'll show me what the call stack was when the error occurred. And it will also allow me to go into any of those functions that were on the call stack and see what the state of the system was, see what the different variables were. So if I go ahead and do this, I'm going to set this option. Now I'm going to rerun that code for which the error occurs. And it says, it now gives me the option of which of these functions do I want to go into. So in this case, I have this idea that, oh, the apply is being called from calcvar. So if I say 2 here, I should go into calcvar and be able to look and see what's going on. Sometimes I get a little bit confused about which one of these means sort of, am I going into that one or am I going into the one above it? So sometimes it takes a little bit of trial and error. Okay, so I might do ls and just try and see what are the objects in the current frame, and that will give me an idea of what things look like. And so I might go in and say, oh, well, what does estimates look like? So maybe I'll do head of estimates, and it'll show me what the values are. I might at this point go back to my functions and just try and remember what is going on in these functions. So I've got this calc_var. So this should be the one that I'm browsing in, that I've gotten into the frame of. And so there's the estimates object, and what I'm about to execute is this. The line of code at which the error occurs is when it executes this function, and then in that function call there's more function calls, and somewhere in there is an error. So I could just sort of verify that indeed this is where the error is happening. So here I am within the function, and I think this will work to basically go in here, and let me just try and run that code. I know this is where the error occurs. Indeed, this confirms to me that that's where the error is happening. And at this point, anybody have a suggestion of what I could do to try and figure out why this is going wrong? So if you think about what an apply does, or what an lapply does, or an sapply does, it's just doing the same function call on a bunch of different individual objects. So it's usually a good idea to just say, well, does it work on one of these pieces? Does it work on the next piece? Is it a problem with one of those 10 different objects? Is it a problem with all of them? So I could, for example, just say, well, what's the var? This is the function I'm applying. Let me just try and apply it to one of the columns of estimates. And indeed, I can already see, well, there's something going wrong with using this function on these columns. Okay. So I might start wondering if there's something wrong with the type of the class of the argument going into the function that's causing this problem. Usually if you see an error that says something on is dot, it means R is checking to see if an object is of a particular type, and if it isn't, then it's returning an error. So we might just go in and say, well, what is estimates? What's the class, say, of estimates of 1? And it says, oh, that's a list. Well, okay, that makes sense. I can't apply the variance function to a list. That's not the right kind of operation. So something is going wrong with the different types of objects that are being used here. So I don't think I want to go into sort of more fully debugging exactly what's going on here, but you could take a step back and say, okay, what is it about the object that's going in here? And you could sort of work your way through, and this sort of gives you some techniques for doing that. Okay, so any questions about that? Okay, so the next thing I wanted to do was talk about basically how do I go in and basically insert a breakpoint so that I don't always have to debug a function from the very first line. So we already saw if you use the debug function, you'll be able to step through the code line by line, starting from the very first line. But oftentimes you know that the problem is happening 100 lines down, or it's happening in some function that's called from another function. And so I may want to basically insert a breakpoint such that I can basically stop the code at that point. So one way to do that would be to manually insert a call to this browser function within your code. So if you have control over your code, you could just basically change your function to have a browser call as one of the lines of the code before wherever it is that you want to stop. There's also a way to use the function called trace to basically insert a call to a line of code that says browser. So let's actually try and do that. I'm not sure if this will quite work here because I don't know if I have Emacs set up in quite the right way. But basically what this is going to do is basically, hopefully what it should do if things are set up right, is open up an editor window with the calc_var function there in the editor such that I could modify the function. I could then insert a browser call wherever I want to in the function. And this is particularly helpful for functions that you don't have control over. So for suppose I wanted to put a call to browser in the 1000th line of the LM function. Well, that's going to be hard because I don't actually have the LM function readily at hand to me. But I could do it using this trace function, which allows me to go into any R function and insert lines of code. So let's actually see what happens here. Okay, so that actually worked. So I could, this is kind of a bad example because it's only 2 lines of code, so it's sort of uninteresting to put the browser call here in the second line of code. But imagine this was 1,000 lines long and I went down to the 900th line and I did this here. This would then allow me to run my overall code, and at the point it'll keep running through until it gets to here, and then it'll stop, and then I'll be able to use N and C for next and continue, or print out objects and things like that. And in here I could do the same thing that why am I forgetting your name? UA, right? That you were asking about the for loop.
Oh.
Yeah, sorry, okay. Let's see. So so I could have, if this were in a for loop, I could have done what I said before of if I equals 9, then I could have called the browser. Okay. And then I can say save, and now if I now I could, for example, I don't think I have debug set up on this yet. I don't think I ran the debug function. I think I did. Hopefully I did undebug. Oh, right. This still. Oh, right. This is because I have the browser in the line after the error occurs, so it instead gives me the whole traceback of the call stack because I didn't even get to the browser statement because the browser statement is after the error occurs. So in this case, you'd have to put the browser statement before the error occurs. But hopefully you can also use this fix function, which does something very similar, and you'll need to have an editor set up to be able to modify the function. Okay, so any questions about that? All right, so let's see one more example, a little bit more extensive and more realistic, although also short. So this is a function, this is actually a function from 1 or 2 years ago that I asked students to write in the second problem set, and it was a function basically having them grapple with scoping and frames in the same way that you guys did in this problem set. So the task was to write a function that when it is called from within some other function will print out the sizes of all the objects that are local to that function. So the idea was that if I create this function called sizes, suppose I'm writing some other function, I could insert a call to the sizes function, and that would, if I want to know how big the objects are, so suppose I'm writing some function myfun that does something, whatever it does, and I want to have some idea at this point in my function of how big are all the objects that I've created and that I'm manipulating. Maybe I'm worried about using up too much memory. So the idea is I would insert a call to this sizes function, and what it should do basically is at this point in time it should print out the size of all of the objects that are currently in this frame. So that was the task for this function to be able to do. And you can imagine it gets into all sorts of scoping and sort of frame issues, because I want this sizes function to be able to look in this frame of this function to see how big the objects are. I don't want it to look in the enclosing environment of sizes. I want it to look in the environment of the function from which sizes was called. So I want it to look in the frame, the next frame up in the call stack. Okay, so I write this function. This was my first attempt to write the function, say. And I say, okay, I'm in the sizes function. I'm going to figure out what's the parent frame, what's the frame from which sizes was called, and then I'm going to do an sapply where I take all of the objects in the parent frame, and I go ask what's the size of those objects. Okay, and then that returns this object to sizes, and then I print that out. Okay, so if I just sort of look at this quickly, it's like, you know, that actually looks pretty good. I think that maybe will maybe work. And you probably won't necessarily see what the problem with it is just by staring at it in the brief time you have available to you. So okay, so I'm going to go ahead and do that. I'm going to make a little test function on which I'm going to test my sizes function. So test fun here is playing the role of myfun over there. I create a few objects of different sizes. This one's going to be somewhat big, this is sort of smallish, and this one's tiny because it's just a scalar, vector of length 1. And then I call sizes, and that should print out how big x, y, and z are. So any questions about the context I'm setting up here? Okay, so now I've defined test fun, and now I need to actually run it. But first, let's see how big objects of those three different sizes are. So they are about 8 megabytes, 8 million bytes, 8,000 bytes, and 48 bytes. Those are how big they are. So that should be the answer that I get. And now I run test fun, and it says, nope, something went wrong. Your sizes of all of your objects are 96. Okay. So there's no syntax errors in the code that I wrote in the sense of it doesn't give an error, but there's a runtime error that I need to debug and see what's happening with it. Okay, so let's go back and insert a call to the browser into let's see, into my getSize function. Sorry, why was I calling it get? Maybe I was originally calling this getSize instead of sizes, so sorry about that. Okay, so maybe I want to be either in here or in here to insert a browser statement and say what is going on, what's the problem here. So I'm just going to manually insert the browser. I could have done this with that trace function or the fix function, but I'm just going to manually insert it because I have control over this function. Okay, and now I'm going to go ahead and rerun my test fun. Okay, and so it put me into debugging mode just like I did when I used the debug function, but now I'm burrowed all the way in here. And now I can do the same sorts of things that I was doing before, and you can see again it's got the browser prompt here. So I could say, okay, well here I am in this function. I'm calling object.size on this thing, and this is maybe where the problem is happening, so I could try and get a better sense of what's going on. So let's see, what does obj look like? Okay, obj is x, so that's maybe that's okay. So I say object.size of obj, so I'm just going to, here I'm just sort of recreating what will happen. I guess I just could hit next as well, but it says, yeah, indeed, that's 96 bytes. I'm like, huh, that's weird. Anybody have an idea of something I could try here?
Assess the size of give it a random variable, see if it's just returning the space used by any assignment.
Okay, so you want me to just try it with anything?
Yeah. Something.
Okay. Let's see. Maybe there's an x somewhere in the scoping here. There is indeed somewhere. I guess yeah. I mean, partly it's sort of not knowing what are the right things what are the right objects to try, because I'd have to think about scoping here. But you might have also noticed that what's going in here is getting evaluated to be a character string, and what I passed in this case was an actual object, with it not as an actual object, not as actually a character string. So it turns out if you were to stare at this a little bit and play around with it a bit, you'd realize, which is what I realized when I was writing the function, that oh, you know what? The problem is it's evaluating the size of a character string of length 1. It's not actually evaluating the size of the object x. So just being able to browse in here was helpful for doing that. And so then I went back to the drawing board and said, okay, here's my second try at this function. I'm going to use a little bit of what's called sort of computing on the language, or sort of manipulating language objects in a more sophisticated way. And we'll learn a bit more about this at the end of Unit 6. But here, all I've done is I've changed my function here that I'm calling from my sapply. I guess maybe I changed this around a little bit to isolate this function. Oh, I guess that's why I had a getSize. And sorry, I didn't mean to make this confusing. But up here, I just used this as an anonymous function. And here, in the second try, I decided to break it out as a named function that then gets called from sapply. But the only substantive difference here is instead of saying object.size of obj, I say take the obj, which I know is coming in as a character string, treat it as a name. So this is a new function that basically coerces a character string to the name of an object, and then evaluate that. And it turns out this works, that if I eval this having coerced it to a name, this will actually give me back the size of the actual object, and not sort of the size of a character string that's sort of standing in as the name of an object. And so if I go ahead and do this, I should get something that makes more sense. Let's see what happened here. Okay. So I still have that option error equals recover turned on so that I get the call stack when an error occurs. So it turns out I was a little bit overly optimistic. My second try still doesn't work, and now I actually have a syntax error in my code, or an error that causes a runtime error in my code. And so if I look at this, what does it say? Well, it says the error is in eval. Okay, so maybe that means this eval. It says the object z is not found. Okay. So, and if I look at the call stack, it sort of makes sense of what happened. I called test fun, then I called sizes, then I called sapply, then I called lapply. You guys have seen this in the homework. Eventually, that called object.size, and somewhere at that point, when it was looking for z, it wasn't able to find it. So that starts to indicate, oh, maybe I've got some sort of scoping problem. It seemingly can't find the z, even though I know that in test fun, I know there's a z when sizes got called. So there's something about it's not finding that z, right? On the other hand, the fact that it got all the way down to saying I can't find the z means it was able to find an x and a y somewhere. So there's something going on with the scoping. And so at this point, you might navigate around a little bit more. You might try some different things. We're running out of time here, so I'll just say a little bit more about what I then did. I realized, okay, there's something going on with the scoping, and somehow in this line of code, when I do the eval and I say treat this as the name of an object and then evaluate it. If you think about where this is happening, this is doing that evaluation in a particular set of, it's doing that evaluation based on R's scoping rules. So it doesn't know that it's supposed to go look up an object z in the parent frame, because I haven't told it that. This is the fixed version of the function. In the second try of the function, it doesn't know, when I do this, it doesn't know to go look for that object in that parent frame. It just goes looks for it in the scoping rules. And so it's probably looking for it in whatever the enclosing environment of object.size is, or maybe in the enclosing environment of getSize. We'd have to sort of stop and think through that more carefully. But it's not then looking in the environment of test fun to look for in the frame of test fun. So then the next thing I did was I say, okay, explicitly look in the environment that is the frame that we're talking about here. And so here I'm going to do object.size sapply. I'm going to list out the names of the objects in the parent frame. I'm going to apply the getSize function, and there's going to be a second argument that says do everything within this PFR, which is going to be the parent frame, which is going to be specifying the frame of the, in this case, of test fun. And then that gets passed along all the way into getSize and into object.size. And this should then work in terms of dealing with the scoping. So it knows to look for x, y, and z, or whatever it is that is coming into sizes, or whatever it is that's coming in as these OBJ objects. It knows to look for them in the right place. Okay, and then I could, oops, I guess I don't actually have a test here, so I just need to go back up here and do it. And if I run it here, then it gives me the answer that is consistent with what I thought it should be based on the original sizes that I looked at before. Okay, so let's finish. We're going to finish there. I may have a few more comments about Unit 5 at the beginning of class on Wednesday, and then we'll launch into Unit 6. Oh, and in terms of another comment about good practices for coding, section today, Jared's going to have you guys look through some different examples of some of the code that you guys wrote for problem set 1 and basically do code review. Not named code review, but he'll just put up some anonymous examples, and you guys will be able to talk through some of the advantages and disadvantages of different solutions.